Good morning, my friends. I'm a little bit under the weather today. I hope I don't look too bedraggled. I am in my solving bathrobe this morning, and we're going to be solving Secret Killer by Philip Newman, which is the gas puzzle originally posted on February 25th, 2024. This is an arrow Sudoku, so we have normal Sudoku rules. We're placing the digits 1 through 9 once each in each row, each column, and each 3x3 region. And we also have arrow Sudoku. So along each of these arrows, the digits that appear on the arrow itself have to sum to whatever value is in the circle. Generally, in arrow Sudoku, you'll see a little addendum in the rules that explains that digits are allowed to repeat along arrows as long as they follow Sudoku rules, so it's not like killer Sudoku in that sense. In this puzzle, that's not necessary just because all of our arrows are within a single row or single column, so digits wouldn't be able to repeat. It is called Secret Killer, I assume, because Philip has been kind enough to give us all of the arrow bulb totals, which means that essentially these are not just arrows, these would also work just as well as killer cages. For instance, we could have a killer cage here with a sum of 3, or a killer cage here with a sum of 4, etc. But Philip has presented it as arrows. It's a very aesthetically pleasing puzzle with this run of consecutive digits along the diagonal. Let's go ahead and solve it. So I'm going to pencil in the restricted arrow totals first because we have all of the totals. I'm going to pencil in the restricted values. So 4 is always 1 plus 3. 3 is always 1 plus 2, so the 2 must go there because there's a 1 in that region already, and that's going to be a 1. 5 has 2 options, but one of them is 1 plus 4, and we know it can't be that because this cell can't be either 1 or 4. So this 5 has to be 2 plus 3, there and there. 6 also has 2 options, and because we have 2 arrows pointing opposite directions that see each other, we're going to be using both of them. So one of those is going to be 2 and 4, and the other one will be 1 and 5. Let's see what digits we can put in. So here, we can't place 1, 2, or 4, so this must be the 5 with a 1. And then this has to be the 2, 4 pair. Now I don't want to move immediately to the higher totals. Let's look at some of the lower totals over here that are off this diagonal. So 7 needs a low digit, 1, 2, or 3, and then a medium digit, 4, 5, or 6. So we can't use a 2 or a 3, so this must be a 1 plus 6. Now there's already a 6 in this region, so that's our 1, and there's our 6. 6, once again, is either 1 and 5 or 2 and 4. In this column, we've used 1, 2, and 5, so that has to be 4 and 2 in that order. This is our next lowest available total. This can't be 1 and 6 because of the 6 in the row, so this is either 2 and 5 or 3 and 4, and I can't tell which one just yet, but we'll get there in a moment. Now let's return to our diagonal. So 8 has to either be 1 and 7, 2 and 6, or 3 and 5, but we've already now used the low digits 1 and 2, so this has to be a 3, 5 pair. 9, there are actually 4 ways to make that, but we've eliminated 3 of them using just these 3 digits in the row. So we can't be doing 2 plus 7, we can't be doing 3 plus 6, and we can't be doing 4 plus 5. So this 9 has to be 1 plus 8, and because of the 8 here, we know which way around that goes. This 9, since we've eliminated 1, 2, and 3 in the row, can only be 4 plus 5. And that leaves us with one more arrow. Let's see if we can bag this one too. So we can't put a 3 on this arrow at all because there are 3s in both of these rows. So this has to be either a 2 and a 6 or a 1 and a 7. And I actually don't know just yet which one of those it's going to be, but as we do some Sudoku, that should make itself clear. So let's have a look at some Sudoku here. So here we need to place 1, 4, 8, and 9. This cell can't contain 1 or 4, so that's going to be 8 or 9. This cell also can't contain 1, 4, or 8. So there's our 9. There's our 8, and now we need a 1, 4 pair. And now this row is almost complete. That'll be a 3, and that 3 will keep us from placing a 3, 4 pair here. That'll be 2 and 5. So no, that's 4 and 2. So now in this region, we still need a 1, a 6, a 7, and a 9. This can only be 1 or 9, this can only be 6 or 7, and we'll leave the rest of it for the time being. The central region is nearly finished. We still need 3, 4, 8, and 9, so these will have to be 3, 4, and 9, because we can't place an 8 in those cells. There's an 8 in the row already. The 3 and 4 in the column make this a 9, which should resolve the entire row. That also gives us this 3-5 pair, which bounces back and gives us this 4-5 pair. Now we need to place 4 and 8 in this region. And we can also finish off this entire row with our last digit being a 9. And now the sum here is 6 and 2, which resolves this 2-5 pair. Let's finish up with some classic Sudoku. So we need to place a 6, 7, and 8 in this row, and what jumps out to me is that I have this 8 along with the 6 that I just placed, which makes this a 7. And now I have 6 and 8 in the two end positions there. I need to place a 7 and a 9 here. I don't know which way around those go, so I'll leave them for now. Here I'm going to need a 6, 7, and 8. The 8 can only go up here because there's an 8 in region 8 already. Let's have a 6, 7 pair there, which will give us a 9 and a 7. And the remaining two digits here are going to be 6 and 9. And this is going to be a 1. This looks like our next most restricted row. I need a 3, a 5, and a 7, so this can't be 3 or 7, so it's 5. Then that's our 7, and that's a 3. These columns are also getting quite restricted, only 3 digits left to go in each of them, so this will be 4, 8, and 9. I need to place a 4 there. And the 8 that we just placed will give us that 6, 8. Now I need a 1 in this column, which can't go in this region, so it has to go up here, and a 3 and a 4 to finish off this region. So now I need a 2, 5, and 6. That's not going to be a 5, that's not going to be a 2. I need to place a 3 somewhere in this column, and this is the only position for it, so that's going to be either a 5 or a 6. In this region I need a 7, which can only go here. I need a 2 and a 5, which can only go there and there. My 6 and 9 are now resolved. That's now 5 or 6, and that is a 4. Here I still need a 2 and an 8, which resolves this. And the 6 that I placed earlier gives me that 6 and 7, and now all I need anymore is a 9 and a 7. And that's how you solve Secret Killer by Philip Newman. Thank you very much, Philip, for a lovely, relaxing puzzle, and I hope you have a cozy rest of your day.